Hi, my name is Torsten Schoneberg. I'm a postdoctoral researcher in the Hamby lab from the University of Maryland in the entomology department, and I'm working with the invasive fruit fly spotted-winged Drosophila. Spotted-winged Drosophila is one of the most noxious pests in small fruits such as raspberries, blueberries, or the blackberries right behind me, because it lays its eggs into ripening fruit, and when the consumer actually gets the ripe fruit, they might find larvae inside the fruit, which of course nobody really wants to. The issue is, because it lays its eggs into ripening fruit, it disrupted IPM measures because most farmers currently rely on weekly insecticide treatments. On the other hand, since it's an invasive species coming from Asia, it's sensitive to abiotic conditions such as temperature and relative humidity. The optimum conditions for spotted-winged Drosophila are 22 to 28 degrees Celsius and above 70% relative humidity. In a former pruning experiment where we reduced 25 to 50% of the canes in blackberries or of the entire canopy in blueberries, we observed that we can actually alter the microclimate, which also resulted in small changes of spotted-winged Drosophila infestation. So last year and this year, we modified a V-trellis to an experimental V-trellis and compared it to an I-trellis. The thing about the modified V-trellis is that instead of running 2 wires, we run 4 wires next to each other to split the canopy into halves, instead of having a dense hedge like the I-trellis. In addition, in one half of these plots, we pruned out 25% of the canes to increase the effect of increased airflow, to reduce humidity, and increase temperature and light intensity. By opening up the canopy, we are aiming to affect spotted-winged Drosophila infestation, particularly in the morning and evening hours, because during hot summer months, it's active in the morning and evening hours laying its eggs. And by increasing temperatures and light intensity, we might reduce these hours of activity. As I said, this is the second year of the study, and last year we did not find significant effects between the I-trellis and our experimental trellis. However, we did also not observe a significant yield reduction, and the quality parameters were also the same. So what we did is we measured sweetness in Brix, and we checked for penetration force, which means the firmness of the berry, and they were equivalent in both Trellis experiments. To actually get data on the microclimate, we installed several data loggers within each treatment to capture humidity, temperature, and light intensity, and to set this into a comparison between the treatments and see if this somehow affects spotted-winged Drosophila infestation. We take fruit samples every week, and before we start harvesting the fruit, we take measurements of the berry core temperature. Last year, we were able to raise the temperature in the experimental trellis plots by 2 degrees Fahrenheit, and this already happened around 9 a.m. in the morning. So thinking about going on during the day, this temperature difference between the I-trellis and the experimental trellis might increase, making the berry less favorable for spotted-winged Drosophila. During the last year, we also felt that harvesting felt easier and faster in the experimental trellis plots. So this year we are actually timing ourselves while we are picking the fruit to get some data on this. And another interesting point in this is that you might improve sanitation measures by harvesting all of the fruit from the rows, which reduces potential inoculum sites for spotted-winged Drosophila. Another good point that we might get by opening up the canopy is that we get improved spray coverage and spray deposition. So this year we are doing applications with yellow number 5 to see if we actually get a higher spray coverage within the entire canopy and a higher spray deposition on the berries. In conclusion, comparing the standard I-trellis with our experimental V-trellis, we are hoping to see that we can change the abiotic conditions within the canopy, which means increased temperature, reduced relative humidity, to make the conditions less favorable for spotted-winged Drosophila and thus reduce infestation. We're going to publish this information either on the Hamby Lab website or probably at Fruit and Vegetable News. And if you're a farmer thinking about putting in a new blackberry planting and wants to try a new trellis, you might be on the lookout for this information, and you might want to adopt this to help you control spotted wing Drosophila at your farm.